Yeah, thank you. Thank you very much for coming along. Sorry to interrupt.
Oh, no, I'm sorry.
No. This is what the Maker Faire is about. People meeting and connecting. And my name's Andrew Lamb, and I am part of the mAkE project, which I'll be talking about. And it's all about connecting African and European makerspaces. My own background is as a systems and information engineer, but I never worked as an engineer, mainly because when I studied engineering, it was all maths, and I never did anything with my hands. And I joined a group called Engineers Without Borders, and because they did stuff with their hands. And I was volunteering with them for 6 or 7 years in fundraising. I became their first chief executive, and then through that I met Apropedia, which is a sustainability wiki, which I'm going to plug for a moment, even though it's got nothing to do with mAkE. And then I got involved in disaster relief through an organization called Field Ready. And the whole point of Field Ready was to try and bring the kind of technologies that we see in the Maker Faire into disaster relief, so that we can manufacture aid supplies on demand in disaster zones. So this is Apropedia, where you can go and learn how to make aquaponic systems or water filters or whatever you like. Field Ready is my the last sort of 10 years of my life working in disaster relief, setting up makerspaces in, this is Mariam in Iraq. This is Ramchandra, who's 3D printing spare parts for medical devices in Nepal. This is actually in a hurricane response in the Caribbean. But the whole idea with Field Ready was to manufacture aid supplies locally, and if you manufacture locally using the maker movement and connecting with local manufacturers, then you can do things cheaper, better, faster. The problem that I had at Field Ready, I was meeting all these makerspaces all over the world in different developing countries, and the problem I had more than anything else was, how do you take it to scale? We could make one medical device, like what Ramchandra is doing here. He's repairing a connector on a pump that's very important for providing maternity services. But what we needed in these places was not just one maker space on one maker who may have been able to attend a Fab Academy training or a Maker Faire at some point. What we needed was something a little bit bigger, a network. We needed what we now call the Internet of Production. So now I still work with Field Ready, but I also work with something called the Internet of Production. And it is because of my involvement in the Internet of Production that we got involved in the mAkE project. So I'm going to talk to you a little bit about this. One thing I'd like to say that's unusual perhaps for this particular project is that we actually don't work with any makerspaces. What we work with is networks of makerspaces. So there are, there's the broader maker movement, but you'll be aware that there'll be hackerspaces and makerspaces and fab labs, and there's corporate makerspaces and government university makerspaces. There's all these different types of makerspaces. There are also makerspaces in our network that are more focused on, say, scientific hardware. So Africa OSH. I seem to have lost the tab. This is a network of makerspaces in Africa, across Africa, that focuses on open science hardware. So this is about being able to make your own scientific equipment, to be able to make your own, to be able to do your own experiments, to make your own bioreactors and biomedical, not biomedical, what do you call them? Sort of enzymes for being able to conduct experiments that you wouldn't normally be able to conduct. So Africa OSH is also a member of the consortium. There is another network of makerspaces. This one is based in Germany, called the Global Innovation Gathering. And the Global Innovation Gathering brings together innovators and makers, not just from Europe and Africa, but from all over the world. So we have people from Ethiopia, we have people from Palestine, from Poland, from India, from America, even from Germany, for this German network. And if any of you have attended the Republica conference, which just ran again in June, the Republica conference was really what created this network, because it's like 15,000 people come to this big media conference. And they have a makerspace right in the main hall, right in the center of this enormous conference. So they would invite people, the German government would invite makers to come and to see how things are in Germany, and that's how this network emerged, the Global Innovation Gathering. So, mAkE is made up of, not of makerspaces, but of networks of makerspaces. We call them digital innovation hubs. And the reason for that is because the European Union funding wanted to fund digital innovation hubs. So we had to make the case to the European Commission when they funded this project that actually digital isn't just about software anymore. Digital is also about hardware. And we convinced them and said that makerspaces are a type of digital innovation hub, a digital innovation hub for hardware. So what does the project do? Essentially, we're trying to build an ecosystem. We're trying to build the capacity of makerspaces in Europe and Africa. We're doing things like studying and codifying and creating a catalog of business models for makerspaces. This is quite a big deal, and the business models of makerspaces in Africa are very different to the business models of makerspaces in Europe. I'll come on to that. We're looking at providing venture building. So we have a venture building program as part of it, where we actually do put money and resources and time and effort to help makerspaces to help their members. There is a training, an online, you can do online MOOCs. So rather than sort of one makerspace trying to deliver online training by itself, the network as an ecosystem will be able to have a shared online platform and share online training. There's the area that I'm working on, which is about creating a digital infrastructure for networking together the makerspaces, and that's what I'm going to spend quite a bit of time on later on, so the less said about it now, the better. But the idea is that we're trying to connect these makerspaces in an internet of production. Some of the it may surprise you, but some of the makerspaces in sub-Saharan Africa, North Africa has some very effective, very impactful, long-running makerspaces like in Egypt or in Tunisia. But in sub-Saharan Africa, there are some enormous makerspaces. So there's one called Motive in Uganda, whose website I have not been able to find yet. And motive is absolutely vast. It's funded by the Orange Foundation, but they have these enormous warehouses in the city centre, and I haven't got any good photos of it. But anyway, and they don't just have 1 or 2 or 3 sewing machines, they have 80 sewing machines. They don't just have 1 or 2 3D printers, they have 53 3D printers, because Motive is a makerspace that's about creating jobs. And people go there not to prototype or to learn things, they go there to produce things for sale. Because makerspaces in Africa are very much about earning a livelihood rather than having a hobby. This is one that I've spent quite a bit of time in Nairobi, the Gearbox makerspace. And Gearbox, as well as being very popular with the great and the good, this is the founder, Kamal, who was an engineering academic. There he is. As well as being a place in central Nairobi where they can have lots of famous people come and visit, it is a hub for business development. So there are makers in there that have developed CNC machines that are being sold to car companies in Kenya for the likes of Toyota to be able to make and repair their vehicles. And they have a big facility as well with a co-working space. There's often a lot of maker spaces and co-working spaces working together. In Kumasi, in Ghana, you have this rather wonderful incubator academy co-working space and maker space that is all about trying to generate startups. They have an electric vehicle startup, for example, where they're manufacturing electric cars and electric scooters. But the challenge is still very much, what is the business model? How do we maintain it? How do we keep it running? So if you've never been to an African makerspace, next time you have the opportunity to, please go to one of them, get in touch with me, I can make some introductions, and they'll blow your mind. It's a very different way of working. Now, also in sub-Saharan Africa in particular, there's in Eastern Africa, there's a big refugee crisis. So there are increasingly makerspaces which are focused on working with refugees. In Kakuma, in northern Kenya, in northeastern Kenya, in Lamu, the Kenyan Red Cross has set up a makerspace to work with Somali refugees in the Dadaab refugee camps, one of the biggest, oldest refugee camps in the world. Some of you may know a maker from Milan called Enrico Bassi from OpenDot. He worked with the International Organization for Migration, a UN agency, to set up a makerspace in Djibouti, particularly to work with migrants. So there's also some dedicated makerspaces for the humanitarian sector, which is one of the things I've been very involved in through Field Ready. The other differences are, or quite frankly, you cannot have a makerspace. Generally, in most countries in Africa, you can't have a makerspace that is based on membership fees, because the ability to pay a membership fee, you could get away with charging 10, 15, maybe even $50 a month if you're in a city center location somewhere, if you're looking for corporate clients. But basically, if you want to reach a wider community, you won't be able to charge a fee. So you have to be a member to access these spaces, but it's often the case that the membership fees are a tiny amount of income relative to the cost of a machine, say. relative to the cost of rent. So whereas membership fees in Europe are the mainstay of the revenue of a lot of makerspaces, certainly in my country, they don't work. You know, you only need sort of 15 members in the UK to be able to buy a 3D printer, sort of thing. Whereas you might need 150 to be able to buy a 3D printer in African makerspaces. So there's different business models there. There's also a lot of focus on environmental issues in makerspaces in Europe. Whilst there is an interest in environmental issues in Africa, actually the main focus is on job creation and entrepreneurship, like I said. And if you can make money by being environmentally friendly, fantastic, you know, but it really is. There's two very different paradigms, but at the infrastructure level, they're tackling the same sorts of challenges: managing members, training people up, how to pay the bills. A big challenge for African makerspaces is where you get the materials from. Trying to find flat plywood isn't easy in many of these countries. You know, it might be warped like that. Or they just might not have plywood. Like in Madagascar, really you can't find plywood. So, you know, you can't really use your CNC machine with warped plywood. Or the taxes on importing, there is no 3D printer filament factory yet in Africa. Everything is imported. So the taxes are also a barrier. There are 3D printer manufacturers in several countries. This is African-born 3D printing. These are 3D printers that are made in Kenya, that are made in Nairobi, and they're very popular. They're made in a makerspace that's owned by the company, and many of the components they use to make the 3D printers are e-waste by necessity. So they might find stepper motors from photocopiers and office printers and things like that and repurpose them. But they're really great machines. But yeah, most of the African makerspaces do have a lot of challenges with imports, basically. So, what's going to happen? In an ideal world, once we have all of these makerspaces in Europe and Africa, and they've all got these business models that they can choose from, they have a catalogue of business models they can choose from and figure out how best to run their organization and earn revenue, and sustainability for them often means financial sustainability, not environmental sustainability or social sustainability. Very much means financial sustainability. Once you've got some successful ventures, once you've got some a cohort of trained makers in your membership that will keep coming back and they're running their businesses out of your makerspaces, and once you have some of the infrastructures in place, what are we trying to achieve? Well, what we're trying to achieve is with the idea that makerspaces will become part of the infrastructure of the industrial development of the continent and the re-industrial development of Europe. That rather than having centralized manufacturing that we've had ever since the Industrial Revolution, you know, the fourth Industrial Revolution now apparently, but the idea of everything being made in a factory through mass production processes based on economies of scale that concentrates wealth and power and supply chains in places that are rich with large populations and are easy to get to. That doesn't help in many parts of Europe. It doesn't help in most of Africa, in fact. So the idea is that we help to foster a new paradigm of production, of decentralized and distributed manufacturing, where the makerspaces become almost like services are to the internet. Places where you can just go and get things done, and they're reliable and they're always there. They will be sources for materials and access to machines. They will have a future as assessing the quality of the products that get made, or even certifying those products through peer review processes or government processes. They will have a role in the education and training systems of the countries as well. So to really transform them from being voluntary organizations into long-term parts of the civic infrastructure for a new paradigm of production. I'm going to concentrate a little bit more about on the Internet of Production now. There are some events coming up where we'll be presenting mAkE. You can have a look at them on our website. And we've connected already with a number of other maker ecosystem type things. Sorry. In this book, there are some copies on the top of the lockers there. On page 220, there is I'm very proud. It's one of the first times I've actually written anything about what I do. My colleague Barbara and I have written about building an Internet of Production. So we talk about from distributed design, which is the title of the book, to participatory production. And we say a little bit more about everything that we're talking about in these pages. But just so that you don't have to read it, I'm going to talk about it now. The idea with the Internet of Production is to create some open standard infrastructures that would support local and distributed manufacturing, decentralized manufacturing, and to be able to shift this paradigm from mass production to production by the masses. So the idea is to empower everyone to be able to create and make what they need. From my perspective, in a disaster relief situation, it would basically mean you don't have to wait for aid to be flown in from warehouses far away. You can actually be more resilient and respond more quickly to a crisis. Just as we have seen in the global pandemic of COVID-19, many people were making PPE. Well, actually, you know, makerspaces and some of the makers involved in them, as some of the photos that we've shown, could be making spare parts and making medical devices routinely. Why do we even need to ship that stuff anymore? The Internet of Production is basically about trying to digitize much of these supply chains. But there's a lot of effort going into this, and there's a lot of work around it. The Industry 4.0 approach and the big industry approach to this is very much around how do you do this within companies, or within a supply chain. So if you're trying to make a Toyota Land Cruiser, that's a very aid sector car, sorry. We buy a lot of Toyota Land Cruisers in the aid sector. If you're trying to make a Toyota Land Cruiser, you probably do want to be using the centralized manufacturing for that. You know, nobody really wants to start making a Toyota Land Cruiser through distributed manufacturing. It's going to be really expensive. But industry is trying to make sure that they have this new approach where all of their supply chains and their feed through to the consumers through their distribution channels become much more responsive to consumer demands. That's a lot of what Industry 4.0 is about. The Internet of Production is saying, well, that's fine, but actually we also need a broad base. Rather than just looking vertically and improving, going from raw materials to finished products and responding to consumer demand more quickly within companies or supply chains, we need to look more broadly. So for me, the question of the Internet of Production is about how can you make 200,000 identical products in 2,000 places on a single contract. So I do a lot of work in Nepal. There are medical facilities, tens of thousands of medical clinics all over the country, and I don't have access to a lot of the supply chain, the medical supplies, because that comes through the medical supply division of the Ministry of Health, which is based in Kathmandu, and the supply chains up into the mountains rarely work. A lot of the nurses and doctors that work in these medical centers, the only way they get resupply is if they go to like a family wedding in the city, and then they fill their backpack up, and then they go back into the mountains. What about accommodating a future where you could make 200,000 items in 2,000 locations across the Himalayas to print on demand, and rather than having a warehouse in Kathmandu, you have a digital warehouse online? That's beginning to happen even in many hospitals in my country. There's no reason why it couldn't happen in Nepal, and to leapfrog that technology paradigm that we've had of supply chains. But the trick is really to make that, for me, to make that much more responsive to local innovators, so that local products can be recognized and sold internationally, so that a maker in Nepal who comes up with a medical product can sell that internationally and compete with Siemens and Philips and General Electric. That their innovation can be as successful in the same way that the internet has allowed YouTubers to compete with movie studios. You might have questions about how the contracting would work. The MAKE project is going to do an experiment on this. The last thing any procurement officer wants to do is very large numbers of small contracts. The admin involved in that would be a nightmare. So when I talk about 2,000 contracts, each for 100 parts, a procurement officer would probably faint and just like, that's 10 years of their life gone right there. The idea is to try and do all of that contracting in a single contract for zero marginal overhead cost. So it doesn't make any difference to a procurement officer in the Ministry of Health whether you're placing an order of 200,000 items from a mass producer in China and having it shipped, compared to contracting 2,000 local makers across a network and actually not needing to ship. It would just make on demand for the local context. So we're trying to do it. This is one of the big parts of the MAKE project, is we're trying to really get to distributed manufacturing, not in that vertical supply chain that we often think of in industry, but in that really broad networked manufacturing approach. Wish us luck. We're going to need it. It's going to be hard. But the way we're doing that is we're putting some of the infrastructures in place. So we have, first of all, an initiative called Open Know-how. An Open Know-how is a data standard for the documentation of hardware. And honestly, every maker should know about this. Because what this enables is, these are all the people who wrote it. Right, here are some of the terms. What this enables, let's actually get to the standard. Yeah, okay. What this enables is is you can share the design, and no matter where you share it online, it will be searchable. At the moment, the problem a lot of makers have is that if they end up designing things, first of all, the first step is they end up designing something from scratch. There isn't necessarily always the automatic reaction of seeing if a design already exists for something. But if you do want to look up if something already exists, you have to look on 100+ different maker platforms to try and find the right thing. You have to use Google search type search terms to try and, and then analyze whether the result, is this actually a proven product? Is this a blog post about something that should exist one day? It's a real nightmare trying to find hardware designs online. This data standard is a metadata standard that describes designs. And we actually have a several thousand designs. This is a search result scouring the internet for open hardware manifests, open know-how manifests. And the idea is no matter where you publish, if you publish on your own personal website, on your own field-ready My Organization's website, if you publish on GitHub, if you publish on Wikifactory, if you publish on Thingiverse, if you publish on Welder, if you publish on Instructables, no matter where you publish online, as long as there's an open know-how manifest file, you'll be able to have your product appear in the search result. So the first thing is being able to make hardware documentation more discoverable. So that's live now. And there's a little tool here. I'm going to actually walk you through this. This is how excited I am to tell a Maker Faire about the Open Know-How Manifest. The name of the hardware is a neck brace. Lots of detail goes here. Intended use for the hardware, medical, external use. And then you can go through this and you can say, here's the link to the project. This is where your design files are. You can put a photo of the image. I'm going to publish it under, if there's, well, there wouldn't be any software code, there'll be hardware code. So I'm going to put it under a CERN hardware license. Let me see if I can just type that in. The documentation would be under Creative Commons, and there's no software. Who granted the license? Andrew. And it very helpfully fills all of that in for me. Authors of the manifest file, and basically, you create this manifest and you stick it on the internet somewhere, and anything that faces the web, and the crawlers for the search engines that we're developing will discover it. So one day, in the future, not far from now, when you go to a search engine, what I'm really trying to get towards is you have a search result. This is the Microsoft thing. You can look at images, shopping, videos. One of those options will be hardware. You'll be able to click on it, and there's your designs, no matter which platform they're on. So we're going to have a hardware search enabled by this open know-how standard. Now, the next levels of this we're working on now. Portability and interactivity. We're consulting a community to develop these standards at the moment. Portability is about being able to easily move your documentation from one platform to another. So that isn't a metadata standard, that's actually a format for how you document your hardware design. And interactivity is a real challenge, or interoperability is, if you change your hardware design on one platform, it will update it somewhere else. So you can publish on many different platforms. And that will, over time, that will allow designers to work together based on their favorite software tools rather than having to do file conversions based on whichever software they happen to be using. So once you've got your hardware design, you then need to know where you can make it. And for that, you need the Open Nowhere standard. It's a bit of a strange thing to say, nowhere. Sounds like the word nowhere. You can't make it anywhere. But it was just the nickname that got stuck, and I think it's quite a nice one. And this is a data standard for the geographic location of machines and tools. And you know, you say the facility is Fab Lab Barcelona, the tool is enormous, great big robotic arm that does ceramic. I can't even remember the brand name of that machine. But you create a map of the locations of machines, this one. So this is a map that my colleagues at Field Ready did of the refugee camps of northern Kenya. And you can see that Dano Workshop has a sewing machine, and they've recently made face masks. So you could go to your open know-how design for a face mask. You can say, where can I get this made near me? Or where can I get it made near the Kakuma refugee camps? And then the next bit is who's going to make it and how you do the contracting. So we have tens of thousands, I think about 30,000 machines mapped. By the end of the project, we want to have, this is still a little bit beta, it's not the final user interface, of course. By the end of the project, we want to have every makerspace in Africa mapped, and I would like to have at least half of the makerspaces in Europe mapped. Again, not just the facility, but also the individual machines in those facilities. Because we're focusing on makerspaces. The maps I'm showing you here aren't just for makerspaces. They're soap factories, they are injection molding factories, they are individuals with sewing machines. That's what's in this map. We aren't just going to look at primary data collection, because anyone who's run a makerspace is overwhelmed with surveys already. Please tell us what machines you have. What we're also going to do is connect to existing databases like fablabs.io or the Hackaday database or the Ugandan Manufacturers Association annual membership survey. We're going to connect to systems like that so that people update their data. But in the long run, the reason people will keep their data up to date is because they will be able to win work through the Internet of Production. They'll be able to win contracts. Because if they're on the map, just like if you've got an email address, if you've got a website for your consultancy, you will be able to start winning work. So it's a bit like being a consultant and not having a profile on LinkedIn. Like most consultants have LinkedIn profiles, right? And so I can type in bookkeeper, and then there's 1,000 bookkeepers in my, in Southwest London sort of thing. We're also looking to try to connect with some of the corporate systems that exist for machines and suppliers. There are some enormous, great big databases like SAP Ariba that has like 50,000 manufacturers, 50,000 suppliers registered just in Iraq, that they've developed over years worth of selling their software to people. By connecting with those, we'll be able to also very rapidly fill this map in. As you can see, at the moment, we don't have a lot of data from Europe. And we haven't prioritized collecting it from Europe, quite frankly, because there are lots of other databases, including fablabs.io, that have already done it. So, I'm encouraging every makerspace in Europe and in Africa to create an open nowhere profile. And then what was I going to say about next? Right. I can't show you. We haven't got a prototype yet, but let me see if I can find. Sorry, I thought I had the browser tab open, but it doesn't look like it. The next thing to do, once you know where the machines are and once you've got your designs, you need to know who's going to make it. And all over the maker movement, if you have a makerspace, you have some kind of access control system for your makerspace. So this is a good example of one. The reason I think it's a good example is it's quite popular in Wyoming, huge in Wyoming in America. But the idea is that, and there's another one called FabMan, which is out of Vienna, Happy Lab in Vienna. But the idea is that these systems grant you control, access to a machine in a fab lab. What we're trying to do in the mAkE project is work with some of these existing systems, but also work with skills, education and badging, open badging systems to essentially create what we're calling a maker passport. And a maker passport is going to be really something as simple as a mutual recognition scheme between European and African makerspaces. I mean, I want this to be beyond the project, but for the mAkE project, it could just be within the members of the project. A mutual recognition scheme to say that if a person has learned to use a Prusa 3D printer in the Motive makerspace in Kampala, then when they go to the Gearbox makerspace in Nairobi, they don't have to do the training again. They can just start work. There's a mutual recognition scheme in place for credentializing people's work. It begins to inform quality, because if you can begin to figure out how many times, or how much time somebody has spent on a particular machine, or how many products they've sold through an internet of production, you will get some indication of how good a maker they are, and therefore the quality of what you're going to get through the network. This idea of doing 200,000 products in 2,000 locations on a single contract, that bit's the easy bit. The hard bit is how you do distributed quality control, distributed quality assurance. Who checks that those products are identical? What if in one place they don't have the plastic 3D printer solution, but they've been able to find an identical, they've been able to make the same design but on a wood lathe instead? Who checks that functionally the device is the same? And I think the idea of distributed quality control and how we do insurances and warranties, that's all going to come later on, but it's sort of out of scope for this project. Right now, it's about a maker passport to encourage mobility, to know that someone from Fab Lab Barcelona can go to Gearbox in Kenya, or could go to Motive in Uganda and just start work and not have to retrain, basically. That's actually quite a big barrier for a lot of makerspaces. So there's the maker passport, and then we've got the contracting system. And the contracting system at the moment is a Ethereum-based smart contracting thing that doesn't have a web interface, it doesn't have a user interface, it's a command line system that we developed in Nepal. It doesn't have to be based on blockchain. It just so happened that we had some funding at the time that enabled us to work with Ethereum. So we developed a prototype on Ethereum. But the idea is to be able to get to that distributed contract. So hopefully in 3 years' time, I will be here talking with you, trying to persuade you to buy something that can be made in 2,000 locations across Europe and Africa. Or even just 2 locations, it's fine. Maybe you want to send a gift to your friend in Poland. Don't send it through the post. Don't order it from China, get it here, and send it through the post. Use the internet of production and use local distribution. And you can have an identical product made over there. But hopefully, in 2-3 years' time, I'll be able to come back and show you how to make things with makerspaces in Africa and Europe using this ecosystem that we're developing. I focus very much on the technical infrastructure side of things. I haven't focused very much on the business models or on the venture building or on the training. There's other people in the project who can spend a lot of time talking about that, and if you've got ideas for that, please do approach me. I'll connect you with them. But I'm very happy to be able to present mAkE to you today, and I'm excited to hear if you have any questions and doubts and advice and comments. Thank you very much for listening. I've convinced everyone. No,
just on the last part that you were saying that we're using for protecting the contract, or to sign up the contract using Ethereum. Right?
The prototype we have at the moment, the proof of concept is on Ethereum.
I was wondering how the, let's say, sustainability of the blockchain system can match, like there are a lot of controversial thoughts